Hey everybody, Scott Mann here, noisechop.com. Today I'm going to talk to you about blob tracking. Blob tracking is part of the OpenCV computer vision library. That's what the CV stands for. And it's a way of taking in data and aggregating it into shapes that have a position and an amount of time that is on screen. Generally, this would be a person interacting with something, some installation that you've built, and it's sort of a quick and dirty way, and very useful quick and dirty way of getting the position and some other data of shapes in the field of view of some kind of sensor. In this case, the sensor is an interactive floor. This floor has sensors in it which are either on or off. When the sensor gets covered, it sends out a 1, and when it's not covered, it sends out a 0. And this is what this data looks like coming in. So this is the input side. Just quickly, I built this network with my buddy Greg Moncada, AKA Bad Pedestrian. You can look him up on his Instagram. He's a great artist and creative tech, based in New York. When he's not jaywalking, he's doing stuff like this. And we built this network together. So quick shout out to Greg. We built this for the Rochester Jazz Festival for a particular sponsor who we didn't want to interact with for the purposes of making this video. So I'm just using footage from our test run in the AV facility. So where was I when I interrupted myself? Oh, yes. Sensor data came in off of this floor. Looks like this. The blob tracker aggregated that data into blobs. That's what the rectangles are. And out of that, I got a position, which is a UV. And I also tracked the age of each blob. And that is all the data that I used to make this installation, which is why it's a nice example, because it's fairly simple, even though the results are kind of fun. So I get a UV position off of each of these blobs and track the age, and I am instancing a circle that grows over time, and it's messed up with a little noise and stuff just to give it a little texture. That's why it doesn't look perfectly circular, and I'll go over what these little plops are. And then that whole output is fed into a fluid simulator, which is where the magic kind of happens visually. I'm not really going to talk about the fluid simulator, but I will point you to where I got it. Anyway, that's just the big picture. I'm going to take a little detour now just to talk about blob tracking in general. If you may be using a camera, in this example, I'm going to use a depth sensor. I have my Kinect set up right here. And just to tie it to the general world of blob tracking, because if you're using a camera, your data is obviously not going to look like this. But this conversation is still germane to anything that you might be doing with a different type of sensor or camera. So I'm going to go over that briefly, and then I'm going to come back. I'm not going to do a step-by-step build of this network, but I will get pretty granular into how all of this is working. Okay, so here we are in a new network, and we're going to look at blob tracking with a depth camera. I've got my Kinect Azure sitting right up here next to my webcam. Drop that in, set it to depth. So I get a depth reading off of this. What exactly does that mean? It means that any color value coming off of this thing is actually a distance value. So I don't know if you can see my mouse in here, but I've got it right in the middle of my chest, and you can see down here that the RGB values in the middle of my chest are about 0.9. That means that this pixel that I'm pointing to is 0.9 meters away from the lens of the camera. And then I'm going to move up to this wall back here in the back, and you'll see that the values are now 5. That wall is 5 meters behind me. And that's all the data that you get off of the depth camera. but it's kind of three-dimensional, right? So I'm just going to quickly flip this so that it's not confusing. It looks like a mirror. And null, and then into a threshold. And why am I doing this? Because blob trackers, the enemy of a blob tracker is, of course, noise. It's seeing stuff that you don't want to track. And let's say this is like palm trees blowing around back here. In this case, the problem is that there's just a lot of noise coming off of the Kinect because it can't read these smooth surfaces accurately. And if it shoots the laser out and it doesn't get a reading back, it assumes that that's a zero. It just assigns it a 0. So if you were to plug this into a blob tracker, you would get a lot of noise. And noise is a problem with floors, with sensors. There's noise coming off of the floors, and there are different ways of dealing with that. In the case of a depth camera, the way to get rid of it is with a threshold. And there's sort of a magic trick. And this is, again, a bit of a tangent, but I'm just going to cover it anyway because if you are using blob tracking and you're using it with a depth camera, this is a trick that you'll want to know. So again, I'm getting a depth reading. When I go into the threshold, I set it to greater. You think of a threshold as like a throwaway. What should I throw away? The threshold is asking you, what pixels should I throw away or assign a value of 0, which comes back as black, right? If I set the threshold to be around 1, I'm going to make it a little higher because that's where I'm sitting. It's basically saying, okay, any value that's greater than 1.176 is now going to be 0. Okay, so you can see that the wall behind me, like this area right in here, right by my left. My right ear? I don't know because it's a mirror image. The wall behind me is getting mostly assigned black, right? Because it's greater than a 1.176. And I am in the foreground as white. But all of this noise, this stuff that it can't register and can't read is coming back as a 0. Which it assigns to be black. And that's giving me the noise problem. What happens if I multiply these together? Third time's a charm. Right? Nice, clean signal. Okay? And if you think about it, that's because, well, anything that was greater than my threshold in here, anything greater than 1.176 is getting zeroed out. Otherwise, it's getting zeroed out by the depth camera itself because it's not getting a reading there. So one or the other 0 will be in the multiplication for that particular pixel. So you'll always get black for the stuff that you don't want. So right now, all it's showing me is what it sees within 1.176 meters of the camera, right? And you'll see that as my hand goes outside of that range, it just disappears. And this is a way to create an active area for your depth camera in your near field of view. So now I'm going to essentially plug this into a blob tracker. There's my blob track. Okay. Let's put another null right here, I guess, just I'm a good person. Okay, so what is the blob tracker looking for? The blob tracker is looking for aggregated shapes. Right now, it looks like all it's seeing is this guy right up here. But when you plug in only the top input of the blob tracker, you're getting what is called simple blob detection. Simple blob detection is a blob detection algorithm, OpenCV. This method will automatically use if only the first input is connected. Blob tracker has the benefit of not requiring a known background to detect blobs, but only returns blobs as a position and radius. Okay, so I don't know what it's doing to decide what's a blob and what's not, but basically don't do this. always give it a background. And the main reason is performance. Maybe there's a use case that I'm not thinking of that you would want to use simple blob detection. What we are doing is called background subtraction. So what we're doing is we're looking at a background and comparing it to what is coming. We're looking at the second input, which is the background image, comparing it to the first image, and then looking at a threshold. Where's the threshold? Oh, here it is. It's grayed out because I don't have anything plugged into the background yet. And then it's just taking a difference reading between those two. And if that meets a certain threshold rating, then it says, yes, this is an active pixel. Something is happening. Something is moving. Something is different from the background, right? So I'm going to plug this into my null here. And the way to get a snapshot of your background is to just get everybody out of the field of view. Unfortunately, I have my microphones here, so I'm sort of stuck with those. So I'm going to get a little quieter because you're not going to hear my voice as much far from the mic. So I'm going to duck my head under the table and then lock this null, okay? Did I get it? Okay. So, again, I got microphones and stuff. And if you're doing this in an installation, you wouldn't have this problem. Microphones floating around in front of your camera. Anyway, so this is like the background, the there's no people here state of the blob tracker, right? So now I plug that in and I get blobs being made. Hooray. This is just the basic way that you would, set up a blob tracker with a depth cam. Now, unless it was like a magic mirror close-up type of installation, the camera would be a little further away, and your people. I'm gonna move my elbows into the dead zone back there so that it separates my hands. But like right now, my minimum blob size is too big. Okay, there we go. So what I'm doing is just like I'm putting my elbows out of the field of view so that my hands are being blobified. I got 3 or 4 blobs here right now, I guess, but in a normal installation, I wouldn't be filling the field of view. I would be, the little people would be like more like my hands here, or my little people walking around. And the blob tracker will put out a position, which in the case of like this blob right here would be in the middle of the blob. And then it's got a big blob here, which is my body. But you could have a field of view. If it was a wider field of view, you might have 10 different blobs, and maybe there are people walking down the street here, and you could track them and instance a shape on top of them or what have you. So now, general note about it. The way I like to work is to I put a threshold before the blob tracker. So I probably should have thresholded this as well, but I'm just going to do another threshold. Okay. I'll put one in right here too. So now all of my pixels, I can set my threshold kind of low here, I guess. All of my pixels that are coming in are either a 1 or a 0, right? So you can see that. And this is really ultimately like blob tracking. It has to make a decision about every pixel. Like, is this a yes or is this a no? Is this an active pixel or isn't it? So I just kind of like to see the world the way that the blob tracker is seeing it, because it operates monochromatically as well. One of the first things you want to do when you get the blob track open is you have to tell it what channel to look at. You could look at luminance, which is sort of an aggregate color. I just would tell it to look at the red channel. Red, green, and blue are all the same in this case. So just tell it to look at the red channel. Now I know that if I've got one in the red channel, meaning I have a white pixel that I have action. And if I don't, so now I'm kind of seeing the world the way that the blob tracker sees it. This is not required by any stretch. You could plug your camera straight into it and set the threshold, and then maybe that would give you a better sense because you can actually see actual video of what the camera is doing. Personally, I just like to see what the blob tracker is seeing. And the blob tracker, like any binary decision, has to eventually decide between yes and no. And I think it just sort of simplifies it. So there you go. Okay, here we are back in the interactive floor network. I already sort of walked you through what we're doing. Just to review it again, we are tracking blobs coming in off of the sensor data and instancing circles that grow over time and feeding those circles into a fluid simulator to get this effect, right? Of course, my video freezes. There we go. Okay, so everywhere you step, it creates a growing ring, run it through a fluid simulator, and fun. When you plug into an interactive floor, what you're going to get is something that looks almost exactly like this. Use this as my test case. The final output of the floor was it that low? I think it was. Yeah, 1008 over 504, pretty low resolution. That's because the pixels are pretty big, and they're kind of indestructible, and the sensors are built into them also, so they need a little space between the pixels. So that is the final resolution. I just took the floor data and stretched it out to be that, to pretend that this was like an aspect ratio that matched what was on the floor, but I actually just kind of stretched it. But normally you would be getting something different. Quick note about sensor data. Well, in this case, 96 by 96, what this means is each pixel is represented, each sensor is represented by a pixel, okay? So what is coming in has nothing to do with the screen or necessarily even the aspect ratio of the screen. It's just like a map of which sensors are firing, and each pixel represents the sensor. So if this was one panel of the floor, this would just be telling me which ones are on and which ones are off. I just stupidly fit this to be the aspect ratio of the actual floor, and then I ran it through a threshold just the way I did with the depth camera. So each pixel is telling me whether it's on or off. I'm using a resolution top to lower the resolution. So now back into blob tracking. Here's my blob tracker. If I don't plug in, again, for slow blob tracking, I don't know if I mentioned this before, if I don't plug in a black background image, this thing is going to run very inefficiently. Quick note about efficiency. You're not going to get this thing running on your CPU a whole lot faster than 12 milliseconds. It's a computationally intensive process, and that's something to be aware of. If you have other parts of your network that are like super chop heavy or super CPU heavy, it's not leaving you a lot of headroom, but this thing is doing so much work for you that in the two cases that I used it last year, it was more than worth it. And it didn't render my CPU headroom unusable at all. I did a much bigger one than this, and it was totally fine. So, but just word to the wise, you're not going to have a ton of CPU headroom with a blob tracker. You can shave a little bit of your performance by simply lowering the resolution. So now that I have my aspect ratio, it looks like I knocked this down by 70, I knocked it down to a quarter of the resolution. And that may seem painful, but like, it's really not. Blob tracking is aggregating, averaging data. That's what we're doing in general anyways. So lowering the resolution does not really ding its precision that much. Like, it's sort of trying to give you a general sense of where things are happening and how long they've been around and how big they are, et cetera. Lowering the resolution doesn't really hurt you. I don't know how much CPU time I'd get, probably get back a few lose a few milliseconds if I ran this thing at full resolution, but it just made absolutely no difference to the precision of my UVs. So you can get really aggressive about lowering the resolution of your input to your blob track. My background image, of course, is just a constant. It's nothing. If there's nobody on this floor, then there should not be any sensors firing and giving me an on signal. But unfortunately, that is never the case. There's I don't know. Let's see. Let's take a look. In this case, this was, I think, one panel of the floor, and there are 9,000 sensors just in that panel. There's like a 96 by 96. There's lots of them there, and they're about a half an inch apart, or maybe a little more or less. But there's thousands of sensors, and the idea that none of them will be malfunctioning is virtually impossible. If you just have a sensor that is stuck in on mode, you get everybody off the floor, and you run it into a null just the way you would with the depth camera. And let's say all these sensors, if I stopped it, these sensors are all just freaking out, and then you just lock it, and you basically just tell it to ignore those sensors. Now, this would be very extreme. You wouldn't get noise that looked like this. Noise is usually kind of speckly. You lose some sensors, you lock them out, no big deal. You're also going to lose some of those little speckles when you set the minimum blob size. So maybe that'll solve the problem for you, but I just wanted to talk about noise for 1 second because it's always a problem of one kind or another. Okay. At long last, we get to talk about the blob tracker specifically. As you can see, my floor data is coming in as these little clusters of pixels. And minimum blob size and maximum blob size. Like, I made my minimum blob size pretty low, but let's say it was like, if I made it really tiny, then like it's going to chop up people's feet into like 2 blobs. Like what you want to do is kind of try to figure out, and you just use the slider, like, okay, like what is about the size of a person's foot in Blob Track land? And I don't remember where it was, but I'll put it back to that value. Okay, 0.012 is about the size, I guess, of somebody's foot. And that's what I want to track mainly is feet. Somebody, did lie down on it at one point and it worked okay. But for the most part, it's people walking around, right? So maximum blob size, this probably could be pretty low. If you had a camera and you had people walking up close, then the maximum blob size would be more of an issue. And, if somebody walked like filled the field of view and it was larger than this maximum blob size, that blob wouldn't track. So maximum move distance has to do with when should I retain a blob and when should I create a new blob? And this is a tough one for this particular project because, the idea was that every time somebody steps somewhere and triggers a blob, that a ring would be created and grow out. If you move your foot, then the whole ring moves with you, and that's actually not how fluid behaves. Like the ring that from the disturbance should just stay stationary. As you can see, some of them sort of move anyway, and what I just decided to do was to make them the maximum move distance very small, so it would basically create new blobs most of the time, right? If I turn this way up, then you can see that like my rings are really moving around. And a little bit of that is okay in practice, even though it's completely physically not the way that waters work, that fluid works. This was sort of the simplest way, just like, we're not going to move the blobs around that much. Just make a new one if there's any significant movement going on. Delete nearby blobs in this case all blobs are considered equal. If you were sort of person tracking with a camera field of view, you might want to do this in case so that their hand and their head wouldn't be seen as separate blobs. It would assign them to the same blob. But I just left these off so that like every blob, if you see a blob, I want a UV position on that blob. And I'm not doing revival. This is if like, let's say there are people walking through a camera or something and lost a blob and then it came back, it would want to revive as the same blob. I didn't do revival because of the nature of the fluid simulator, just sort of like tended to smooth out any of those issues. So those are my settings in the blob tracker. The threshold, again, it doesn't really matter because I'm already thresholding my input. So all of this data is either 1 or 0. And I kind of recommend that you do that. It makes this basically irrelevant because either it's less than 1 or more than 1, and all of these values are the same in that regard, right? So what information are we getting from it? Well, we're getting a UV position and age. Now, if you set up an info dat, you can see all of the various data that you can get off of it. Since I'm not doing any revival, all of that stuff is zeroed out. But each blob is born. It has a static position. It sits there for a while and then it dies, goes away. Okay. So I'm just going to look at the first thread of data, which is the UV. So I plopped an info chop. Let me just stop this so we don't go insane. So here's each blob's UV width and height. No age. That's a bug in TouchDesigner. So any TouchDesigner people watching this, you left that out of the info spawn from the Blob Track, but we worked around it here. So if you need age, then you can't get it out of an info chop, but you can get everything else. Then I just selected out blob data, right? So blob plus whatever is the star. Anything that starts with BLOB gets kept. Everything else is discarded. Shuffle chop. I used to hate this chop because I didn't understand it, but now I love it and it's my best friend. Sequence every nth channel, right? So I want to aggregate each blob parameter or data type into its own set, its own channel here, right? So sequence every nth. So I got 1, 2, 3, 4, 5 channels, data channels for each blob, and I want to sequence every nth channel. So now the ID, the U, the V, the width is all going to be aggregated into one data set by the shuffle chop. Wonderful friend. And then here's a select. I just went in here and I said blob U and blob V. The math chop is multiplying the only U data times 2. Okay. Why? Because this is UV data. It's just giving you a fraction of the distance expressed as a number between 0 and 1 from the origin, right? So if I was to stop this prior to the math chop, this U data is giving me, I don't know, let's call this 0.25. That is just telling me that on the horizontal axis, this pixel is 1/4 of the way from left to right. And when it comes down to instancing, I've got to match up my UVs with the aspect ratio, which is 2:1. So all U data has to be multiplied times 2, right? And if I was to instance this data straight away, it would be instancing it on a square, and it's instancing on a rectangle. So I just, once you feed something through the blob tracker, coming back out, you have to regain your original aspect ratio. And now I have an index and a UV value for each blob. And that's how I'm getting my position data in my geo. Okay. Translate op is null pos, and I got UV for each one. For all the rest of the data, I'm using age. Age was not in my info chop, so I set up an info dat, which did catch it. It is the 9th column here. It's age. And so I just, since the start column and the end column is the same, I just dragged this into here, and so that I'm getting the right data. It's the 9th column, and as you can see, oh, it didn't label it age. Okay, well, you can see that I've grabbed the correct data set that I'm looking for. So I want the age of each blob, dat to chop, right? And I don't know why I'm using a select here. This could just be a null, I guess. Then I'm running it into a math chop. And the reason that I'm doing that, let me get the rendering image up here. View. Okay. So each graphic is just a circle with a dot in the middle of it, and that is my constant material right here. So I just stuck that inside the geo for the sake of cleanliness, but this is my little graphic. I just made a circle and a dot. I comped them together and ran it into my material. That's what's being rendered. And each little blob's age is being tracked, and I am converting that into a size. So I just wanted to multiply that times 5. If I multiplied it times 10, you'll see that each one is growing faster and getting bigger and bigger and bigger. If I put a 1 in here, now they're very small. 5 ended up being the value that I wanted. So hilariously, there apparently are blobs here that are like 100 seconds old, and I don't see any. If it was, I don't see any here. And the reason for that is that we're using age to decrease the color values and essentially the opacity of each instance. So over time, it eventually hits opacity 0 and disappears. So if you go and stand stationary on the floor and just let the rings go out, eventually they just fade away. And that just seemed to work best. When it gets to a certain level, eventually opacity is 0, even though the blob is still technically on the screen, right? Here's where I just renamed the channel to age for the sake of clarity. And then I drop that into my instance, and I scale X and Y by age. That should be pretty straightforward. Oh, I skipped the shuffle chop. See, I'm afraid of the shuffle chop. To get from here to here, just swap channels and samples, right? Because I only have one data type here. So I just need to take this graph and get it this way. Opacity, color data, instance data, right? I have a value of age that is increasing over time, but I want to use that value to decrease the color values. And I'm just going to skip ahead for a second. I don't know why I have this problem, but I can't seem to get alpha to work just on its own in an instancing network. I'm sure it's possible to do. I don't really know what these things mean. I usually just like monkey around with them until it starts working, but I didn't need color out of them anyway. So I just assigned age to RGB and A. I don't know why this is so problematic for me, but like it is. The way I did this, and there's probably a better way to do this with like an inversion or something, but this worked, and this is the way I did it. There may be a better way, but I assigned a constant to a value of 6, and my thinking was, well, I think I kind of want it to be on the screen for about 6 seconds. essentially what I'm doing is taking the age and subtracting it from 6 for each blob, right? So you can see now for each blob, they're going down, 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 down. Now, the ones that are on screen for a really long time, this person's really standing there for a while, well, they go below 0, so they're invisible. And same thing, shuffle, swap channels and samples, right? And then I limited this to 6 and a 0 just because I don't want negative color values in there just for safety's sake. There's no reason to be sending them values that are meaningless. So you can see now for each of my little blobs, it starts at 6, a color value of 6, and starts to fade down. So 6 is kind of arbitrary in terms of color values because my little graphic here already has some opacity information. I didn't overthink this. I just like played around with the opacity of my graphic and the value of 6 counting down to 0 until it seemed to work okay. Again, there's probably a better way to do this, but this worked great. And I think what's actually happening is that it might not immediately start to fade, like only when it gets down to a value of like 1 does it actually start to fade out, and that seemed to work for me. So one of the problems that we had was that when you stepped somewhere, this thing was like a little too slow. It didn't give an immediate like satisfying splat. So we created a separate geo just for splats. Same exact idea. UV is coming from the exact same place. The positional data is the same. And then I made a little quick splat, right? So it lasts only for 2 seconds. Same approach. I don't need to walk through it again. And then, so I get these two guys right here, right? And they're kind of clicky. Right? They disappear. The second the blob disappears, they're gone. That instance no longer exists. Same thing with these guys. The way to handle that is just to run it through a little pre-processing. Nothing's going on down here. This is just basic normal feedback that we're all familiar with. Right? I'm turning down the opacity a little bit, feeding it back so that it kind of smears, and then when the blob goes away, it fades out. If you don't know what I'm talking about, look at any number of a million tutorials about feedback and opacity. This just creates some echo in the visual. So it gives me a nice smooth fade out. Now, one thing that's not realistic about it is that when the person's foot moves, that blob stops growing. If it was a real ripple, it would continue growing. But the fluid simulator itself accounts for some of that. And it just, I don't know, visually, it didn't really end up being a problem. So this is what I'm feeding to my fluid simulator. I'm getting a splat, and then the longer ones get a longer ring treatment, and this is what that looks like, right? So you see the little splats, and that gives you a little satisfying splat when the person walks around. So we can view these again. Right, as the person walks around, the splat kind of guarantees that you'll get a little reaction. This is sort of a better view of it. Right, so you can see, we'll wait till I actually walk around. There I go. So only when I stop does the ring become, that's my primary instancing, but the splat actually ended up being just as important. Another thing you'll notice is that the splats are late. And the reason for that is that there's latency in the floor system. Like I could not get this. This is the fastest I could get the data. It comes in behind, and that is a struggle. And I hope that latency for the floors themselves will improve. But there's a good like 100 millisecond delay between when a sensor fires and when the data comes through NDI and reaches the network. And we tried everything that we could to optimize it, but this is the best that we could do. I've worked with 2 different versions of this, and both of them had a similar amount of latency. I don't know if it's because the data has to travel a long way. It's got to burble up through NDI and then get into TouchDesigner where it's registered, and all of that creates latency. So that was a problem, but it was still fun and awesome, and the installation was a success. One other quick insert that I promised to mention is that I got this fluid simulator from a dev who's got a YouTube channel called 3 Dashes, TouchDesigner 06 Fluid Simulation. He goes through all the math and everything, but he then just goes in and shows you how to write the code and set up this fluid simulator. It takes a long time, and it's challenging. It's a great fluid simulator. I just wanted to give him props. It's a beautiful fluid sim, and he did an excellent job explaining it. Thank you, 3 Dashes. I think that's it. I've probably gone on way longer than my allotted time. I'll try to cut it down for you. I hope this was useful to all of you. And in the meantime, have fun with blob tracking. If you have questions, please feel free to put them in the comments and I will try to answer them for you. Peace out and Happy New Year.
Hey folks, thanks for watching. If you like our YouTube content, I highly recommend you check out the Interactive and Immersive HQ Pro. The HQ Pro is the only comprehensive educational resource and community for immersive design, TouchDesigner, and creative tech pros. In the HQ Pro trainings, we cover almost any topic you can think of, and we go way more in depth than we do in our YouTube tutorials. We have a private group where Matthew Reagan, myself, and our other industry veteran and pioneer teachers answer your questions every single day. If that sounds cool, click the link in the description to learn more. And if you enjoyed this video, hit that like button and don't forget to subscribe for more free TouchDesigner and immersive content.